Anastasija Nikiforova from University of Tartu, Estonia, is today with us. Thank you for being here, and the virtual stage is yours.
Thank you very much. So let me start. As it was already introduced, and thank you very much for introduction. Same as thank you very much for accepting our talk for this conference. We will talk about the framework for understanding quantum computing use cases from a multidisciplinary perspective and future research directions, which was developed by a team of the authors. More precisely, actually, you can see that all of them are listed here, and we are 10 in number, if I'm not mistaken, and we represent different countries, namely Estonia, Finland, Germany, Romania, Latvia. And there is also one co-author from the QWorld Association. So basically, we are close to this community. One slide, which was not originally expected to be here, but it is just a reference to the presentation we just had from Julia, which was, from my perspective, just excellent. And why this slide is actually here, because she referred to the team, to the network of the universities called Delta. But I am from Estonia, and I'm sitting currently in our main building called Delta. So this is just coincidence, but I decided that I cannot miss this detail. And now, not to waste the time, let me start talking about the actual study. Unfortunately or fortunately, there are many things to be discussed, and therefore maybe some of them will not be so very detailed as I would like to have them. But nevertheless, you can see in very many slides we will have a reference to our original article, which is publicly available on arXiv in an open access, and it is already available in a Discord. So should you have an interest, do not hesitate to refer to the article. Should you have any questions afterwards reading or something like that, do not hesitate to contact us. But anyway, everything I will manage to cover during this talk, I will try to do as good as possible. So let us start with study rationale. Obviously, it is more or less clear, but still. Recently, there has been increasing awareness of the tremendous opportunities inherent in quantum computing, and they are also discussed during this conference. The speed and efficiency of quantum computers will significantly impact the Internet of Things, cryptography, finance, and marketing. So basically, the very first point refers to what is actually in place, so the increased interest, and there are many more in the future, of course. And there has been increased quantum computing research funding from national and regional governments and private firms, considering this huge potential, but there are critical concerns regarding legal, political, and business-related policies related to quantum computing adoption, including also not limited to ethical concerns, which were also mentioned by Julia, and not only. And since this is an emerging and highly technical domain, very many studies focus heavily on the technical aspects of quantum computing, which is not so very in line with the previous talk, because we saw this relatively rare exception, but still, the vast majority of them are focused on technical perspective. And considering the fact that it is the case and there is no coherent framework on the business, legal, and policy perspectives of quantum computing from an interdisciplinary perspective, we decided to come up with such a preliminary version of the framework. So it is not in any case a final solution and a silver bullet to be taken and just replicated, reproduced, and etc. But it is rather a starting point to start with something. Because actually this study, born as a part of application for the project funding, we tried to obtain. Unfortunately, we failed, but we failed at a very late stage. So basically, we are more or less satisfied with this. So all in all, the purpose of this study is to provide such a preliminary framework for the business, legal, and political perspectives of quantum computing and a solid future research agenda to be potentially used as a reference point by others who are interested in this area, but maybe do not know clearly where to start or how to formulate research questions. So basically, to use it as a reference model. And also to highlight its practical and social use cases which are needed for the increased interest of governments to support these initiatives, which is actually the case for several countries, but not for all countries, because of course we just heard that in the Netherlands it is already the case, and the Dutch movement is very active in this sense. It is also the case for academia in Estonia, but not the government. It is also the case for government in US, in Germany, and etc., but not in all countries. So it is rather a call for action from our side. For the methods we have employed, the starting point for this was an extensive review of the literature where we referred to Scopus considered to be the most comprehensive overview of the world's research findings by using several search queries, so combining quantum computing and business, law, national security, politics, and etc. And it returns some number of studies, more precisely more than 1,000. And after our initial screening and subsequent thorough screening of the items by excluding those which are completely irrelevant for our study, or which are purely technical articles, we end up with 21 useful items, which is not sufficient knowledge base to base something on it. So we decided that given the current state of the research, that a gray literature review would be more appropriate. So basically we complemented this knowledge base with the results from other sources and by the items such as Forbes, IPS, European Information Repositories, Acts, and etc. Although Acts do not exist in a very high number yet. Then, considering the output we received, we understood that various themes emerged from the studies, and we would like to structure this somehow. And to better understand these themes and to structure this knowledge somehow, we follow the classification by Duety and his co-authors, which embodies three broad areas, namely environment, user, and application areas, and subsequent dominant subthemes. So you can see here what we obtained as the very end result. I don't know whether the pane is only for me, which is cutting slightly the model, but it is not so very important here. So basically, it cuts only arrows. So here we can see that we have the three above mentioned elements: environment, users, applications, broken down into smaller subcategories. Such for environment, we identified ecosystem, security, institutional change, and geopolitics and jurisprudence. We will cover most of them just in a very few seconds. For the users, we identified that the current body of knowledge, it is not to say that this is a very comprehensive overview, because also you have just heard that we covered Scopus, so actually is a limitation, only one digital base, and so without preprint servers and etc., just those which are already indexed in Scopus, but it is a very new feature. So some studies most probably have been overlooked, unfortunately, but still. So for the users, we identified countries, firms, and related to the firm's customers, of course, and for the application areas, business and finance, renewable energy, medicine and pharmaceuticals, and manufacturing. Here, of course, from application areas, we can also see that actually the list is not very comprehensive, because we know about many more application areas when quantum computing is expected to bring some benefits, but it is what we observed from those studies from the sample we had. Now let us dive into slightly more detail regarding those areas we have identified. So for the very first area, namely environment, quantum technology is changing the institution of the market and the fundamental structures of marketplaces, such as the architecture of the digital technology-oriented internet, and it changes also the agenda of the players, of those multiple players we have, such as policy programs, investment projects, and it also triggers an overall institutional change. And the environment surrounding quantum computing adoption is formed by ecosystem, security, institutional change, geopolitics, and jurisprudence. For the ecosystem, while recent research has proven many industrial applications, the ecosystem approach is critical for increasing the adoption of quantum computing technology. And actually, for those people who are familiar with the ecosystem approach, it is something very obvious, because actually each and every new phenomenon is expected to be studied by applying the ecosystem approach, because it is seen to be a very valuable asset and tool in understanding how everything looks like. So basically the whole image, the whole picture of the phenomena. Various components and relationships between them describe how an ecosystem approach can accelerate the use of quantum computing in social and business domains, but not limited to them only. These were just in which my colleagues were most interested. And this included 3 action areas and 2 enablers identified previously by one of the researchers, and actually the reference can be seen also in the slide, and will be also provided at the very last slide. For those action areas, for those 3 areas, there are industry use cases which are expected to substantiate quantum value for industry, collaboration that would foster cross-industry, academia, policymaker, hard work, software developer, and startups collaboration, and any other stakeholders we can imagine. And market incubation expected to initiate a quantum computing market by creating a demand. As for enablers, we have identified, actually retrieved from that article, 2 of them: talent and education, associated with the current and expected growth of the quantum workforce, which is already an issue. So we know that the demand for these specific skills are lacking, and we refer to this item as quantum literacy. So actually, we also consider that quantum literacy has to be defined, because this term, to the best of our knowledge, does not exist, and it should be form-shaped and brought on the table. And for the second enabler, it is standard, so expected to establish common interfaces, including but not limited to common terminologies that are crucial for its successful realization. I will skip one of those sub areas, because actually I see that my time is coming to the end slightly. Therefore, I will have to somehow to wrap up this and to move to another category. So security, we decided to skip during this presentation, because there are very many conversations with regard to security, and I don't want to repeat everything, because actually it relies on the existing knowledge based on the existing literature, etc. So institutional change and geopolitics, the main message here is that it will really for this institutional change and geopolitics will be affected, and actually it is already the case, because quantum computing is considered to be a central part of Chinese power strategy, yet other countries emphasize technological supremacy as a sign of power in the international arena. And also it tends to be seen that the key question in the global context of quantum computing, quantum technology, artificial intelligence, so basically emerging and disruptive technologies, is whether technocracy with state capitalism, such as Chinese, and Confucian ethics will prevail over Western market economics and democracy, in which quantum technology and AI systems are understood as a series of individual liberties. But still, it refers to the fact that actually this one advancement, which could be seen as either for academia or for the business, actually changes everything around. And this is also the case for jurisprudence, and with the reference to those very many legislative acts, including but not limited to GDPR and etc., whether they will be possible, whether they will be able to cope with post-quantum cryptography or not, or any changes will be needed there in protecting our data, our information, and ourselves, our personal artifacts. And also there is a question of uniform regulation of quantum technology at regional level. So basically at European Union level, we just got familiar with the very first AI Digital Act, whether it will be also the case for quantum technology or rather not, and whether it will be something on the very high level, so basically for the world, most likely no, or it will be rather regional, most likely yes. And for the users, we also identified that there is a very strict, very expressive centrality of the users, which include countries, national governments, firms that deploy quantum computers for the operation and efficient customer services, and of course customers and individuals at the very core, and not only customers from the marketing perspective, and rather just citizens from the government individual perspective. So basically, yeah, we can see those two levels, individual user factors. So it remains to be seen to what extent the use of quantum computers will become widespread in society. But it is clear that it affects somehow, and actually remaining reliving on those recent advancements, we can see that even those advancements which typically are not so very associated with some effects on the individual users and etc., such as generative AIs and etc., already are in place. So basically this paradigm has changed, and most probably for the individual user, now it will be also the case for quantum computing. How to identify whether it will be and at what extent? Models can provide clues to this, such as technology acceptance models, so TAM or UTAUT or whatever, or IRT, as it is typically the case for very many new technologies or just new advancements in the area. So the key factors for spreading a new technology in society are perceived usefulness and perceived ease of use, and they are in the core of this TAM model. And it is expected to be just explored, but most probably in the near future we will see such studies. Coming to the society-wide adoption, it is also the case when quantum computers will be available for general use by the public, and how strong the range of their benefits will be for private individuals. So it is society-wide versus individual, but they are very interlinked. And Of course, the use by the general population might be very limited due to very many factors, and I will not dive into detail, but some of them are pretty obvious and we understand them. But whether it is really the case, we will see just with the time, whether the spread and establishment of quantum computing in society will remain inhibited until they demonstrate broader utility and comfort of use remain also to be seen. At the very same time, society's high positive expectations towards quantum computing, although we can argue whether all of them are so very positive or whether there is some balance and there are some negative consequences or expectations from the society, it is always the question. But there are very many positive expectations, especially from business and from academia. However, due to a strong social component of this topic, a significant deviation from previous model conception is also conceivable. But basically, with the reference to the above, most probably the research of our Dutch colleagues with the representative of Julia would be able to answer those questions, at least at a very tentative level right now. And for the application areas, so we identified several of them, and actually they range from engineering to business and to the applied science, and they were already listed. I will not go through the table. This is rather to indicate that something has been identified as already existing. They typically refer to some expectations, so where it is expected to benefit some potential industry or what could be the key cornerstones. But in some cases, it is also possible to see right now some quantitative analysis of such benefits where some simulation is conducted. So within the business domain, it is clear that marketers are constantly faced with the challenge of achieving a high conversion rate with online advertisement. And there are already studies which tried to adopt a digital annealer, which is quantum-inspired computer, and they already estimated online advertisement conversion rate and accuracy was increased, and of course the time devoted to this task decreased significantly. So the expectations towards this domain is very high. This is also the case within the same domain with a reference to recommender systems to simplify the challenges of displaying relevant recommendation to the target audience, and at least two more or less recent studies dated back to 2021 have been conducted, and also improvements were found and derived from it and also quantified at some extent. And also it is seen that quantum computing has transformational effects on the financial service sector, included but not limited to estimating credit risk, which in comparison with the current approaches is expected to be more accurate and faster. However, at the very same time, it was also the case with AI, but at the very same time, we see a lot of failures when we completely rely on AI only. So it is also the question of whether the adoption will be so very high, and even if the adoption will be very high, what will be the consequences, whether everyone will be satisfied or some pitfalls will arise from this. Another area is renewable energy, which is very topical considering the current state of the art in the world. So the adoption and scale up of renewable resources in the next few decades will introduce many new challenges to the electrical grid we will have to combat, and quantum computing is expected to be one of those remedies. Here, some researchers found that areas where quantum computing is likely to contribute with the reference to renewable energy are very many. So it is not a very single aspect related to renewable energy, but rather many of them, namely simulation, scheduling, dispatching, reliability analysis, and others. Same as in very many cases, which can be actually generalized and be applicable not only to renewable energy. Quantum computing is seen as a very serious improvement in issues concerning the scalability of current approaches, which is relevant for renewable energy, but of course not only for it, considering the current state of the art. And according to other researchers, quantum computing will be also helpful in designing new materials such as lightweight batteries for cars, airplanes, new catalysts that produce fertilizers more efficiently, more effective medicines, and etc. And with the reference to this last, the medicine was also found to be a separate cluster of those studies and also of those areas seen to be as the main beneficiaries from quantum computing developments, which is actually related to the fact of the very classical to the very basics of quantum computers. So basically, the existence of both 1 and 0 simultaneously, which could provide an immense power to the machine and allow to successfully map molecules, and also could potentially open new opportunities for pharmaceutical research, including not limited developing vaccines and drugs several dozen times faster, which is especially topical in these times, considering our recent experience with pandemics, and also some of critical problems that could be solved via quantum computer were identified to be as follows: improving the nitrogen fixation process for creating ammonia-based fertilizer, whatever it means, creating a room temperature superconductor, removing carbon dioxide for a better climate, creating solid-state batteries, and others. So basically, it is not only just to say that most probably in these areas they will be beneficial, but we already can see a very specific issue that could be resolved if it would become true. And it is also the case for manufacturing, but for the sake of saving time, I will not elaborate on this in very many details, just mention several buzzwords, such as they are expected to contribute to the development of autonomous driving software, car-to-car communication in almost real time, which is considered to be a silver bullet, optimized vehicle reading, improving fleet efficiency and availability, especially with a reference to shared mobility players. And also another critical use involves helping mobility providers simulate complex economic scenarios that allow them to predict how demand will vary by geography. And as regards the agenda for future research, here is a main structured overview of what is expected to be the next step. So basically, the future research in quantum computing, considering our corpus we studied, can be divided into 3 categories: user level, key domain, focal areas. Of course, they can overlap. For user level, the main user categories and main stakeholders or actors are government, industrial, business, and individual user and consumer. Of course, we could mention more of them, but they are those which implied very clearly from those studies. For key domains, environment and application areas, where with the reference to application area, financial services, management and well-being, marketing services, and data privacy are expected to be seen as the main areas for the future research. And for the environment, adoption, security, politics, and economy, which is not a surprise, are also expected to be very popular. Then we broke down those potential research directions by the areas we identified, so basically environment and application areas and users, and also considering those categories we identified, namely adoption, security, politics, and the economy, and financial services, management and well-being, and marketing services, and data privacy. We also tried, based on those literature and those open questions or defined research agenda and etc., we tried to derive from them potential research questions. So unfortunately, I don't have time to dive into them. So basically, it remains just in the case you are interested, do not hesitate to refer to our article and later on to discuss with us or to proceed independently. So just to wrap up, despite the potential massive opportunities and use cases, scholars echo 3 main concerns, namely the high cost of integrating quantum computing into everyday life, the attendant security challenges, and the lack of policy framework by government for its adoption. Experts also warn that quantum computing will have a fundamental impact on every aspect of our lives, with the reference to Forbes, and actually you can see that it is already a very outdated citation dated back from 2019. So because more recent citation was that quantum computing is already here. And the framework from an interdisciplinary perspective is very critical because it is already here and it will affect every aspect of our lives. So basically, we have to consider not only technical perspective, but rather interdisciplinary approach and perspective, which is critical to understand the potential impact of quantum computing on society, which is vital to improve strategic planning, management by governments and other stakeholders. And this study provided a very preliminary version of a framework for understanding the social, economic, and political use cases for quantum computing and solid future agenda in the form of research questions we have not managed to cover, but still they exist, that will be critical for the adoption of quantum computing by the government. And the insights offered by various contributors from diverse disciplines, so basically the list of the authors, the team. Our team consisted of business, information systems, quantum computing, political science, and law, which offers a broad-based view of the potential of quantum computing to different aspects of our technological, economic, and social lives. But once again, it is just a very preliminary vision, which of course is expected to be continued. Thank you very much for your attention, and just in the case you're interested, references are provided, the presentation will be made available, and also the study, the full text is already in the open access. Thank you very much.
Thank you, Anastasija. It was a great talk, and I'm really looking forward to the paper. I actually remember seeing the paper, but I think if people are interested, they will find it on archive, right?
Yep. And it is already available in Discord, if I'm not mistaken.
Oh, that's perfect. So if anyone is interested, they can check it on Discord. And even further, since we are recording this talk, if anybody wants to, re-listen this, they can do it afterwards when we upload this to YouTube. And so now I think there was a question while you were doing your presentation, and I will. Okay. Again, Rafael asks, my major challenge is to actually provide resources to local people I'm trying to help. Do you know, are there efforts to create like a universal quantum toolkit with Legos or something similar? So maybe we can you can a little bit elaborate on these existing tools or existing methods in making these technologies more accessible.
Thank you very much for this question. I don't see it in the chat, so I don't know who to say thank you, but nevertheless. So actually, the point is that I cannot say for sure for today, for the today's situation, but actually, as I mentioned, this paper has been written as part of the application for the funding for the project. We wanted to have as a consortium together with my colleagues. At some point, actually, it was 2 years ago or so, maybe slightly less. And the reason for applying for such a funding was that, to the best of our understanding, such a toolkit does not exist. It tends to exist with the reference to very purely technical aspects. But while I am from information systems and computer science and actual software engineer by the education, I'm not so very familiar with quantum computing. But at the very same time, I was one of the most knowledgeable person in our team. So I will not be competent to speculate or postulate on such an availability with the reference to technological solutions. But as regards the whole toolkit of the methods, of the vocabularies, of the general understanding, and etc., as we can hear from Julia, so depending on how do we define this, of course, something happens, something exists, and something is under production, and it is a very dynamic scenario, and therefore I cannot say for sure that it really doesn't exist. It had not existed at some point, and I had not double-checked this for now. But at the very same time, yes, it should be also mentioned that, of course, there exists something. So in the Netherlands, there is a very active research in this area. In Germany, so basically when I refer to the ecosystem approach and the environment, how it looks like, it was also the reference to the German current developments in this area. And actually, it is there is already a task force consisting of different actors from different industries, which are trying to do it at a national level. So it also depends on whether it is with a reference to something universal, whether it is something accessible, available, that everyone can connect, or rather some initiatives and local efforts are in place. For the local efforts, yes, for sure, but it is difficult to find them. So it is just for your personal contacts in the case you want, you can access them. Otherwise, I am not very familiar and aware of the existing, and it would be nice to know if it really exists.
Yeah, thank you. I think that's exactly the case, because it would rather be difficult to develop something that is universal and everybody can use it at everywhere in every language. So that's really difficult. And if you are looking for something local, I suspect there are certain initiatives in many countries, especially on education and outreach efforts, and it would be good to just identify those. And I mean, if you are interested in this, maybe on Discord you can reach out to us with, you know, depending on which local context you are speaking about, and maybe we can help. Also, if you can reach out to Anastasija, I'm sure that she would also be happy to help to the best of her knowledge.